Hello everyone, welcome to the class. This is Mohan Raj, your trainer, and this is Genesis Training Videos. Today we are going to see second video in number theory, that is divisibility rule. It is one of the important rule for us to do the calculations faster. Let us see what is this rule and what we see in this concept. So let us understand the divisibility rule for few numbers. What is divisibility rule? For example, if I am saying a number x is divisible by 5, what is the rule it has to follow? So that by looking at number 5 itself, number x itself, I should be able to say whether it is divisible by 5 or not. So let us see exactly what is this. So we have to check the rule for numbers from 1 to 9 and including 10 and 11. For 1 there is no rule because all the numbers are divisible by 1, and for 2 we can easily say all the even numbers are divisible by 2, right? And 3, digital sum must be divisible by 3. What do you mean by digital sum? For example, if I give a number like this, whether this number is divisible by 3 or not. So what I need to do is I need to add all the digits and then check whether this number is divisible by 3 or not, this sum. So what is the sum here? I get 7, 12, 20, 25, 28. This is not divisible by 3. That means this number is not divisible by 3. I'll give you one more example, whether this number is divisible by 3 or not. So what I should do is I should add these digits again. I'm getting 12, 15 plus 3, 18. So 18 is divisible by 3. That means I can say this number is divisible by 3. So let's see the rule for 4. Value of the last 2 digits must be divisible by 4. For example, if I give a number like this, I need to know whether this number is divisible by 4 or not. So we just have to check the last 2 digits. 52 is actually divisible by 4. 52 by 4 is 13. That means this number is divisible by 4. So why? What is the reason? The reason is because every 100 is a multiple of 4. So whichever 100 you take, 200 is divisible by 4, 300 is divisible by 4, so 700 is divisible by 4. That means every 100 is a multiple of 4. So in this number I have 85400, so which is divisible by 4. The left out number is only 52. I just have to check whether that number is divisible by 4 or not. So last 2 digits. We can also remember 4 means 2 power 2. For even number 2, we check last 1 digit because 2 power 1. For 2 power 2, we can check last 2 digits. Okay. So now we can see the rule for 5. For 5, everybody knows the number should be ending with either 0 or 5. So that's very simple. Coming to 8, last 3 digits must be divisible by 8. So as you can see, 8 is nothing but 2 cube. Also the reason is every 1000 is a multiple of 8. So we check only last 3 digits. So that is enough to check whether the given number is divisible by 8 or not. So next 9. 9, again digital sum should be divisible by 9. So this is very similar to 3. What we do for 3, same thing we will do for 9 also. But at the end the sum has to be divisible by 9 here. So what is the sum? Let's see. 8 plus 4, 12, 15, 19, 24 and then 30. This 30 is not a multiple of 9. That means this number is not a multiple of 9. Very simple. And for 10, last digit must be 0. If it is ending with 0, the entire value will be divisible by 10. For 11, what is it? Let me take an example. I need to check whether this number is divisible by 11 or not. So what I will do is I will add the alternate digits separately. Let's see what is sum of this number. 1 plus 5, 6, 6 plus 3, 9, 9 plus 1, 10. So 8 plus 6, 14, plus 2, 16, 16 plus 8, 24. This difference is actually 14. But I want this difference to be 0 or any multiple of 11. But in this case it is not, so it is not a multiple of 11. That is what I am telling you. Difference between sum of the alternate digits should be equal to 0 or multiples of 11. In this case, it is not a multiple of 11. Now I left one number which is 6, and we don't have to know the rule for 7. 6 is very important. With the help of 6 I can find the rule for other composite numbers. So what is the rule for 6? First 6 can be written as, the factors of 6 are 1, 2, 3 and 6. In this, two prime factors are 2 and 3. They don't have any common factor. So in that way, if a number is divisible by 2 and also divisible by 3, I can say the number is divisible by 6. Using the same rule, similar rule, I can tell what is the rule for 12. So 12 should be expressed as two numbers which do not have any common factor. So 2 into 6 is possible, 4 into 3 is possible, but I need to rule out this and I need to take this one. That is because they don't have any common factor. A number divisible by 4 and divisible by 3 will be definitely divisible by 12. Okay, so if you want to talk about 24, I need to take 8 and 3, not any other number. If you take 6 and 4, they have a common factor 2 common to both of them, which will not work. A number divisible by 8 and divisible by 3 will be definitely divisible by 24. So what are these numbers? These numbers do not have any common factor and they behave like a prime number when they are together. So that is why we call them as co-prime numbers. What are co-prime numbers? Two or more numbers which do not have any common factors other than 1 are called co-prime numbers. They need not be prime. For example, in case of 4 and 3, 3 is prime, 4 is not. In case of 8 and 3, 8 is not, 3 is prime. But I can also take a number 36 which can be written as 9 into 4, where both are not prime numbers but they behave like a prime number when they are together. And remember, 4 is not co-prime with any other number. It's co-prime with 9. Okay, so 4 is not co-prime with 8. That means this particular property is not for the number, it is for the combination. Right? So we need to understand. So using this rule, I can tell divisibility for any composite number. For 36, we already checked 9 into 4. A number which is divisible by 9 and divisible by 4 will be definitely divisible by 36. So now let us go to the examples. Find the missing digit in 1, 5, 6, 4. One thing is missing, one digit is missing. If it is divisible by 9. What is the rule for 9? We need to add all the digits and check digital sum. 1 plus 5, 6, plus 6, 12, 12 plus 4, 16, 16 plus 2, 18, 18 plus 5 is 23. But this is not multiple of 9. What is the missing digit? So I can say that as x. That means I can say 23 by x must be divisible by 9. What is the possible value of x? So x must be equal to 4. Then it will become 27. Then 27 will be divisible by 9. So the missing digit is 4. And this question cannot be answered using the calculator even if it is allowed. Only if you know the rule, you can answer this question. So find the missing digit in this number if this is divisible by 11. To check whether this number is divisible by 11 or not, I need to add the alternate digits. So this pair is missing here. I'll keep it as x. And I'll add this first. 4 plus 5, 2 plus 5, 7, 7 plus 4, 11, 11 plus 5, 16. 16 minus something should give you 0, or 16 minus the same should give you any multiple of 11. Let's see. It's not minus, actually it's difference. So if I can understand this can be 16 possibly. If it is 16, what is the sum we are expecting? We have this number 6 plus 4, 10, 10 plus 2, 12, 12 plus x. Okay, so to make it 11, if this difference is to be 11, I will be expecting 27 or 5. So 27 minus 16 is 11, which is ruled out because 12 plus nothing will give you 27, one digit number. Similarly, 5 is also ruled out because already sum is crossing 5. So I should be expecting this only. So what is the missing digit? It has to be 4. Then only it will become 16 and then the difference will become 0. So the missing digit here is 4 again. Let's see the next example. Find the missing digit in the number 5, 2, missing number 4, 5, 6 is divisible by 12 or not. What is the rule for 12? First we have to split into co-prime numbers 4 into 3. And if the number is divisible by 4 and divisible by 3, I can say the entire value is divisible by 3. But finding the rule for 4 is easy. We have to check the last two digits, and I can say 56 is divisible by 4. 4 14s are 56. That means 4 rule is followed. I need to only check for 3 now. And we know the rule for 3. I need to add the digits. 5 plus 2 plus 4 plus 5 plus 6 plus some number x. This sum should be divisible by 3. What is the sum we are getting? 7 plus 4 11. 11 plus 5 16. 16 plus 6 22 plus x. To make it a multiple of 3, it has to be 2. The missing digit is 2. So that is the answer for this question. Next question. 4235, this particular number, 42351 x 5 y, these are unknown numbers x and y, divisible by 12. Find the highest possible value of x and y. So for first, the number has to be divisible by 12 means I need to have this entire sum must be divisible by 3, sum of the digits, and the last two digits should be multiple of 4. Right? So let us see first 5y, what are the possible value of y? So it is a multiple of 4. So y can be 2, or y can be 6, or y can be 52, 56, and then 60 is not possible. Y can take either 2 or 6. Similarly, what about x? So now x depends upon what value of y am I taking. So if I take 2 as a number, what is the sum of the digits? 4 plus 2 6, 6 plus 3 9, 9 plus 5 14, 14 plus 1 15, 15 plus 5 20, 22. If I am taking 22, x can be what? This has to be divisible by 3 means x can be 2 as well. So when x is 2, y can also be 2. Suppose if I taken y as 6, then what happens? 4 plus 2 6, 6 plus 3 9, 9 plus 5 14, 14 plus 1 15, 15 plus 5 20. I'll be having 26 plus x. So if I'm taking y as 6, x will be equal to 1. So now, because this will become 27 when we take x as 1. What is the question? Highest possible value of x plus y. There are two values of x plus y. One x plus y is 2 plus 2 4. Another x plus y is 6 plus 1 7. So the highest possible value is 7. So this is how tricky the questions can be. The last question in this video, we have 8 4 3 2 x y. This is divisible by 36. So for 36, what is the rule? The number has to be divisible by its co-prime factors product. 9 into 4 36. It has to be divisible by 9 and divisible by 4. And what are the possible combinations of x and y? That is the question. So first, for 4, what are the possibilities? xy can be 2 zeros, xy can be 0 4, xy can be 0 8, xy can be 12, xy can be 16. Like that, the number goes on. But we need to also look at the sum. What is the sum we are expecting? Let us look at the sum first, because the digital sum should be divisible by 9. Let's see what is this number here. 8 plus 4 12, 12 plus 3 15, 15 plus 2 17. 17 means this x plus y can be 1, and that x plus y, right? So this sum again I'm telling you, 8 plus 4 12, 12 plus 5 17. So I should be expecting 18, one possibility, or I can go for 10, x plus y can be 10, or again I can go for 17 plus 19. So x plus y can be 19, but can we expect 19 from 2 digits? Not possible. Some of the 2 digits cannot exceed 18. The highest number I can get is 18. So this can be ruled out. All the other numbers can be ruled out. Now what I am expecting is x plus y as 1 or x plus y as 10. If x plus y is 1, which number I can take? Can I take 0 1? No. 1 0? No. That means this value is ruled out. So I cannot have 1. So I can only expect 10. For this to be 10, x and y, what are the possible numbers? It has to be divisible by 4 as well. So what I can think about is 64 I can expect. I cannot expect 55, so it has to be multiple of 4. So what else I can expect? 28 I can expect, and 36 I can expect. No, 36 is not possible. So 46 not possible, 55 not possible, 64 is there, 73 not possible, 37 not possible, and there is no other number. There are only two possibilities. It can be 64 or 28. So the possible combination for x and y are 64 and 28. That's the end of the video. So let us meet again in the next video in the number theory. Thank you.